Presenting for Team Sutote is Tennyson Nkhoma, who hails from Malawi and is currently studying agriculture science and natural resource management at Earth University in Costa Rica. Tennyson?
Hello.
Hello, you've been patiently waiting. Thank you so much. How are you feeling today?
I'm very fine, and finally I'm going to present. I've been waiting for so long.
Wonderful. Well, good luck, and the stage is yours.
Thanks so much. Okay, good morning. We are Sustainable Tomato Technology Sutote team. Next. We're a team that will eliminate the use of synthetic pesticides in tomato production by producing organic pesticide made from mixed and sunflower. We also make organic fertilizer made from Tithonia Diversifolia and leverage on the tomato waste for biogas production for cooking. This is a system that will not give any room for the use of inorganic inputs, thereby giving a secure solution to land degradation and environmental restoration. Let's look at the context. Tanzania has a population of 56 billion people, and agriculture contributes 26% of GDP and about 2/3 of total export in Tanzania. Tomato presents 63% of fruit and vegetable crops produced and highly consumed. Next. They're highly consumed because they have high bioactive compounds and high content of vitamins, which help in preventing communicable diseases. Next. But the problem is that there is high use of synthetic pesticide in tomato management, causing accumulation of pesticide in residues in food, and also high pesticide exposure for farmers, causing diseases like cancer, infertility, and even death. And there is also high contamination of water bodies to the extent that in Tanzania, pesticide residues were detected in samples of irrigation water. Next. Our solution lies in the organic pesticide made from Tithonia Diversifolia and also organic fertilizer made from Tithonia Diversifolia mixed with organic waste. We are geared to eliminate the problem of pesticide poisoning for farm workers by leveraging on polyphenols and flavonoids of Tithonia Diversifolia, which are used as medicine for diabetes and hepatitis. Next. This is our socio-economic analysis. We are depending on tomato farmers because they are the ones that determine what consumers should eat, and they are the ones that are suffering so much from the problem of pesticide poisoning. To solve the problem, we're connecting them to the solution provided by Tithonia Diversifolia through selling pesticides and organic fertilizers. And these farmers will also be supplying us with tomato waste that we are going to be using for making fertilizer mixed with Tithonia Diversifolia, and also the other part will be put in biodigesters for biogas production and also fertilizer, which will be sold to them, thereby completing the cycle. Next. Our innovation lies in the use of locally available ornament plants to contribute to sustainability in agriculture, achieving affordability in agricultural inputs. Next. Our solution will lead into reduction in effects of synthetic pesticide and fertilizers products on people's health, and also reduction in contamination of land and water bodies, and also lies in economy because low-income farmers will be able to produce tomatoes using low-cost inputs. Next. Our effective flow of resources will depend on tomato farm and Luaha River, which will be the source of raw materials for Tithonia Diversifolia, and also tomato farms for tomato waste. Our outlet presents the production and sales of Tithonia made pesticides and also fertilizers. We did a prototype for organic pesticides in which we conducted the test in a small tomato farm with 16 tomato plants, which chopped leaves of Mexican sunflower, which were mixed with 5 liters of water for 24 hours and applied in tomato plants twice a week at a dosage of 7 milliliters per plant, 3 weeks after generation. That is the final product that you are seeing. The lesson that we learned is that 90% of concentration of the liquid solution diluted to 15% with water can kill after direct contact insects such as stink bugs, cutworms, tomato hornworms, and other disease-causing insects. Next. We also made a prototype for organic fertilizers in which Tithonia Diversifolia was mixed with kitchen waste, where the large quantity was tomato waste at a ratio of 4:6. And the results showed that the harvested tomato fruits were high in biomass by 50% than unfertilized tomato plants. Next. This is a material analysis. In processing, we're going to achieve 90% of concentration to be diluted to 15% of concentration, and the raw materials is Tithonia Diversifolia with reliable and secure supply, and tomato waste with high organic content. We're also making a comparison between inorganic fertilizers and organic fertilizers. For example, from literature, the optimum rates for the production of fertilizer for sustainable maize production was between 5 and 10 tons hectares higher than the yield for inorganic fertilizers. In packaging, we're going to use recyclable plastic gallons from Sila Africa Company and biodegradable paper bags. And to achieve this recycling, we're going to set collection sites and also incentive will be given to farmers. Next. Our customers are tomato farmers, and we're targeting 1,750 farmers in first year of operation in the Inga region. And according to Minister of Agriculture in Tanzania, this region has more than 30,000 tomato farmers. That means 1,750 farmers is a very achievable target. In addition, in Tanzania, 33% of consumers are willing to pay a premium for organic tomatoes. And a survey that was conducted in 2001, there was a recorded organic area of 55,867 hectares, comprising of 27,000 farms. To maintain our customer relationship, we're going to be having field presentation on our product and also field follow-ups. And the channels that we're going to use is social media advertisement, and point of sale will be retailers, wholesalers, and direct delivery. Next. This is our economic sustainability and feasibility analysis, in which we are going to need a startup of $14,250, where we are going to make a profit of sorry. Solo ponga uno.
Solo ponga uno, pues. Ahí arriba. No, es que él no se mueve. Es ahí, ellos manipulan la presentación.
Okay, the break-even period will be 7.5 months, and after selling 1,093 gallons of organic pesticide and also 937 50 kg bags of organic fertilizers at a price of $4 per organic pesticide and also $11 per fertilizers. The competition we have is from inorganic pesticide, which are and also inorganic fertilizers, which are readily available on the market with well-established brands. But the competitive advantage is that we are going to be the only entity producing organic pesticide with a combined power of controlling sucking pests in tomatoes and other disease-causing insects. The product that we're going to be producing will be affordable and also readily available. And our pesticide is environmentally friendly. For example, it does not kill good birds like bees and monarch butterflies. This is our price. Previous slide, por favor. This is our price analysis, in which our main competitors in pesticides are cypermethrin and also farm guards. And also in fertilizer, the main competitors are Hakika organic fertilizer and also green pasture. But our prices are the ones that are affordable. Next. This is a photo showing bees and monarch butterflies visiting the flowers of Tithonia Diversifolia. Next. We have barriers, yeah. We are foreseeing that there will be challenges on farmers to adopt the use of this new and sustainable solution. But so that we're going to partner with Tanzania Organic Agriculture Movement, TOAMA, and Tanzania Horticultural Association, which already has a base of farmers, and also the other parties finance. But we're looking forward to grant from Wege price competition and also support from Minister of Agriculture in Tanzania and Tanzania Agricultural Development Bank. Next. Before we finish, let's look at the vision for the Tanzanian National Agriculture Policy. I quote, an agricultural sector that is modernized, commercial, highly productive, and profitable, that utilizes natural resources in an overall sustainable manner and acts as an effective basis for intersectoral linkage by the year 2025. Next. This is the team behind the solution, in which two members are in agricultural science, because the wicked problem is in agricultural sector. But to make sure the economic sustainability of the solution, we have a member in business management and entrepreneurship, and another member in medicine, because the wicked problem affects the health of the people. And to ensure that farmers will be producing year-long using irrigation principles and practices, we have one member in water resources and irrigation engineering. And our mentor is Jose Cristino Mega, a professor of phytopathology at F University in Costa Rica. Thank you so much.
Congratulations, Dennison. Wonderful presentation. Thank you so much. While we give the judges a few minutes to discuss what their questions are going to be for you, let's chat. We understand through your bio that you are the co-founder of a research institute and youth empowerment organization in Malawi. Tell us about it. That sounds so incredible.
What we're doing with Research Institute and Youth Empowerment is activating the entrepreneurship and leadership mindset in Malawian youths. And the thing that, for example, what we did as a response to COVID-19 is that we saw that the small business were not operating because we were relying on physical sales. And we made a free training in website programming so that we should at least establish online shopping systems.
Incredible work. Thank you so much. So tell us, what about your team? What is your team's superpower? How well have you worked together?
We have been together for more than 1 year. For example, one of our team member, Miriam, we are together in Research Institute and Youth Empowerment. Winfred, we are together at campus. And the other 2 members are from Tanzania. We have been in contact through Winfred. And we have been in contact for more than 1 year now.
Oh, that's awesome. Well, it shows in your work together. Thank you so much for the wonderful presentation. The judges are going to ask you some questions now. Judges, take it away.
Tennyson, thank you very much for your presentation. I have 2 quick questions, and they're probably repeats from other projects. Well, my first is, you're using tomato waste as the primary part of this. I understand you have a flour that you add to it as well. But what's currently done with the tomato waste, and how does diverting this tomato waste towards your solution have an impact on, you know, what happens to it right now?
Actually, just a minor correction that the main raw material that we're using is Tithonia Diversifolia. Tomato waste for fertilizer production is only be contributing 40%. Okay, now what is happening is that people are just leading tomatoes because when they load, they just flow them.
Great. So of the flour, then, is there a lot of this available, or will you have to like begin growing more in order to reach a scale that's useful to you?
It's really available. Actually, in abandoned bushes and along river banks and along the roads, these flowers are there. But us, we are also going to have a farm where we are going to plant this Tithonia, but the backup will be in Ruaha River, which is located in the target area in Iringa in Tanzania.
Great. Does the growing season for the flower coincide with the availability of the tomato waste as the growing season of the tomato waste?
Actually, there is no growing season. When we leverage on irrigation, for example, we cannot have a growing season. However, we can leverage on the lanes to plant these flowers, but they survive year long because they can grow in semi-arid, arid regions, and even areas with high humidity.
Great, thank you.
Can you tell us a little bit about the growing of the sunflowers? How much land do you need for sunflowers to support a certain amount of, organic food growth? I'm just curious about how much land you're going to have access to in order to support growth of other types of crops.
Actually, in our farm, we only have like 2 hectares for plantation of this Tithonia Diversifolia. But for example, from the prototype, that what we learned is that we only need 5 grams to make a 5 liters of pesticide. That means in a year, we need 7.5 tons only. And this is a very achievable, but we are still more, we have a backup that I said that Ruaha River, but that in case we don't have, or maybe this one in our farm, then you can go there, but only 2 hectares is enough.
Perfect, thank you.
Yeah, and,
thank you. Oh, please go.
Okay, yeah. Well, I'm probably stealing one of these questions from one of the other judges, but it just did bring something up when I saw the bees. Do you have a pollinator support? Is pollination an issue? Or we had some devastating things happen to bees in our country, and was wondering what's going on there. How are you going to address that?
Hey, can you repeat the question?
About the pollination of the flowers.
Mm-hmm.
Is that an issue? Is that are bees just floating around readily available? They fly. Are they pollinating without any problems? Is that a concern?
No, it's not a concern. That photo was put to show how environmental friendly is the pesticide that we are going to be producing using the same sunflower. So these are the pollination agents, which are good buds that we need for production of tomatoes, and they relate well with the product that we're going to use as a raw material.
Okay.
I have a question about scale. Your presentation is very good, and I think that your solution has a lot of promise. I'm curious, first, do you have plans to scale, and what does that look like? And second, in support of that development, do you have a monitoring system or the potential to actually understand the sources that you're relying on so that you don't over extract them as you scale? How do you actually monitor and gather information about, for example, the production of available flowers, your other ingredients, so that as you scale and get larger, you don't over extract or have a problem with the sources that you're relying on?
Yeah, on the part of not over extracting the resources, we're going to be using measuring scales, because we know already that we only need 5 gallons to produce one gallon, and we calculate that we only need this the glands. We're only going to be taking the required glands so that we only produce those ones. And according to the waste for tomatoes, we only need also around 7.5 tons also, where we need this 7.5 tons, 3.5 tons will be for Tithonia, and also 3 tons will be for tomato waste. So we already know those quantities, and we only need to be taking this one so that we don't overuse them and we waste them. And talking about the scale, we are targeting. Talking about the scale, we are first targeting Iringa region, which we understand that has more than 30,000 farmers. And these are the farmers that in Tanzania produce more than 70% of total tomato that that is consumed in Tanzania. And we targeted them, as we are also searching for other markets with other districts like Mogolo and Arusha.
Tennyson, why are these farmers currently using synthetic fertilizers and pesticides, and how will you convince them to change to your product?
Firstly, why they are using synthetic pesticide? Because that is a good solution for them that is available. But we are going to convince them, because in the presentation I put that 33% in a study that was conducted, 33% of people which are consumers in Tanzania, they want to pay, they can pay everything that they have to buy organic tomatoes. And these are the people that that demand farmers to produce. And the switch is like, it will be automatic, because farmers have to produce what consumers need to eat, and they will be forced to buy that one. And to leverage on that one, we are partnering with Tanzanian Organic Agriculture Movement, TOAM, and also Horticulture Production Association, which are also going, which are having already a base of farmers, and we're going to leverage on this number of farmers that they already have, so that we also infiltrate on the market.
But there are organic solutions available already. Why aren't they using them?
Organic options that are available? No, I should say I have not seen the Tithonia, or I mean the organic pesticide on the market that in Tanzania, and I will not say that they are already using them. On compost, yeah, they use, yes. But what we're ensuring is the content of the nutrient content, so that they should produce a high population of azotobacter, which is the nitrogen fixing bacteria, for example.
Okay, thank you. If no one else has a question, I'll just jump in again. Where are you going to be in a year's time with this idea?
In what?
In 1 year's time, where's this idea going to be?
Actually, in 1 year time, That's so long because our plan is that within 6 months, we're going to implement it. For now, we did already a prototype. We already have the final product. What we want now is certification from the Tropical Pesticides Research Institute in Tanzania. And that is very important. If we could obtain this certification, we're going to be ready to sell.
Exciting.
Yeah. So you're already in the process of getting the certification.
Hello?
You're already in the process of getting the certification, so within about 6 months?
Yes. Yes. Actually, we're already in the process of getting this certificate. It's very important.
Great. Excellent.
I'll ask one last question. Is there anything left that you need to prototype before you go into production?
No, we prototyped everything that we need to start the production.
Very good.
Wonderful. Well, thank you, judges, and thank you, Tennyson and Team Sutote. I was just so struck in your bio about your commitment to the intersectionality of economic development and environmental sustainability, and that you noted what others may call waste, you see as resources. Thank you so much for that commitment.